Alright, 4.4, the chain rule. Uh, so, we're just going to see a bunch of examples of this after we go over the rule. The rule with this is for certain scenarios that we cannot apply certain previous rules. Particularly if you look at the example list that you see on our guided notes, you will see a bunch of things like along lines of parentheses, 3x plus 4 to the power of 3, or anything with parentheses and an exponent on the outside, or something that would imply a grouping symbol like so, is going to require a chain rule. I'm going to write two different rules depending on what you prefer or like. Your book has quite a few of ways of displaying the chain rule. These are my two favorites. If you're trying to find a derivative of what this essentially is a composite function, right? If you're finding the derivative of this function, it is equal to the derivative of the outside function, and we keep what's inside the same. I don't want that bracket. Give me this. Times whatever the derivative of the inside is. Okay. So it'll look like that. So you take the derivative on the outside of the function and then multiply it by the derivative on the inside. Okay? First example, we have y equals quantity 4x minus 1 to the third. So in order to find the derivative of this, we are going to bring the exponent up front. Keep what's inside the same. Subtract 1 from the power, and now multiply by what's in the inside. Or the derivative of the inside, I should say. So derivative of 4x minus 1 is 4. And I just realized that I did not mention the other rule that I like of using this. The other rule might be you find the derivative of d over dx of, they like to use u's. You're going to see use a lot in our stating of rules throughout the course of the year. And if you're trying to find the derivative of this, you just bring the exponent up front. Inside stays the same, except we subtract 1 from the exponent, and then we multiply by the derivative, which is essentially what we did here, right? We brought the exponent up front, and then we took 1 away using our power rule, and then multiplied by the derivative, which is what we did. We can simplify this a little bit more too. Let's just multiply 12 parentheses 4x minus 1 to the power of 2. There we go. Alright, second example. So remember we have third root, okay? It's like saying this to the 1/3 power, okay? Identical. So when we go to solve this, bring that 1/3 up front. And then subtract 1, so it's going to be negative 2 over 3. Now, multiply by the derivative of the inside, and that's going to be 18x squared. We'll bring the 3 up front. 3 times 6 is 18. Subtract 1, and it'll be that. So let's make this look a little prettier, okay? So my 18x squared is going to be on the numerator, right? On the denominator, it's 1/3, so 3 will be on the bottom. I should write notation here that we found the derivative, yay. And remember, it's anytime we have a fraction, we can write it as the third root of 6x to the third plus 1 all squared. Because it's 2/3, so the numerator goes inside the exponent, and the denominator is the index. Okay, we can simplify this a little bit more. 18 over 3 is down to 6, so we can do 6x squared over the third root of 6x to the third plus 1 squared. There's your answer. Alright, so we have y equals 1 over x minus 2. We got to apply the chain rule here, because that x minus 2 is like saying x minus 2 to the negative first. Okay, so we apply chain rule, bring that negative 1 up front, subtract 1, so it's going to be negative 1 minus 1 is negative 2, then multiply by the derivative, just 1. Hooray. Let's make it look prettier. So the derivative is equal to, put it in the denominator, it's going to be negative 1 over x minus 2 squared because of this negative sign right here. And there we go. We have the answer. So the next couple problems here we're going to do together, we're combining multiple rules, okay, which is exciting. As you can see, we have division, so we have to use quotient rule here, okay? Hopefully you remember what quotient rule is. So if you remember quotient rule, the denominator goes on first. I'm going to keep it like that for now. And then it's going to be times the derivative of the numerator, which is 1. Well, that worked out not too bad. Minus. X is going to stay x. And then the derivative of square root of x plus 1 is where we have to use chain rule, right? So we have to bring that 1/2 up front, parenthesis, that x squared plus 1 stays the same, but we have to take 1 from the power, so it's going to be 1/2 minus 1, which is negative 1/2, times the derivative, which is 2x. All over the denominator squared, so we have the square root of x squared plus 1 squared. Time for some simplifying. 1 times anything is itself, so I'm just going to leave the x squared plus 1 right here. This whole mess, oh boy, we have x times 1/2 times 2x, which 2 times 1/2 is 1, and then x times x is x squared. And then your denominator, you square the denominator, you're going to get x squared plus 1. If we do a little simplifying here, and when I say a little, I mean if I multiply the top and the bottom by square root of x squared plus 1, what happens? We're going to get x squared plus 1 right here, right? And then when we do it to this, remember, this is like saying it over here, right over here. This is like saying x squared divided by this. So if I'm multiplying it by this, it's going to cancel, which is nice, right? Because we're going to get the square root of x squared plus 1 divided by x squared plus 1. So I'm just going to be left with x squared here, which is pretty nifty, right? And all over, and I do the same to the denominator, so since we don't have an exponent, so it would be like to the x squared plus 1 to the 3/2. How to get 3/2? Because this whole denominator right here is to the first, and when we multiply what's inside the same, you just add the exponents. 1 plus 1/2 is 3/2. X squared minus x squared is nothing, so we're just left with this on the denominator, and if we want to write it in radical form, it will be this, because the numerator goes in with the exponent, denominator is the index. Time for another chain rule dealing with one of our other previously learned rules. So we have that exponent 2, we bring it up front. Now it becomes an exponent 1 now, because you subtract 1, keep what's inside the parentheses the same. Now we have to multiply this by the derivative, and as you see, it's, well, a fraction, and we're dividing. So that means you have to use quotient rule. Fun. So denominator stays the same, multiplied by the derivative of the numerator, which is 1. Okay, that's not too bad. And then we have what's on the numerator, which is x plus 5, times the derivative of the denominator, which is 2x. All over x squared plus 2 squared. Let's do some simplifying to make our lives a little easier. So I'm seeing here, I'm going to keep this part the same. And so 1 times anything is itself. And then I'm going to distribute negative the terms on the right side of the numerator here. And it's going to give me negative 2x squared minus 10x over all of this. Now, more simplification. Let's have our right notation. And when we do that, we're going to get x plus 5 over x squared plus 2. And we're going to get negative x squared minus 10x plus 2 over x squared plus 2 all squared. Now let's combine it all in one, and we'll get 2 parentheses x plus 5 times negative x squared minus 10x plus 2, and then your denominators, x squared plus 2 to power 3, because you have another one there you have to include. So this will be an acceptable final answer. Whee! So we got another one here, and it looks like we're involving what? It looks like our power rule here. How about that? So with our power rule, I'm going to keep that the same, and we need to find the derivative of this square root of 1 minus x squared. So that means we're going to be bringing that 1/2 down, subtract 1/2 minus 1 is going to be negative 1/2, and then next part, derivative of x is 1, so 1 times, and then we keep the 1 minus x squared the same. Hopefully you remember your power rule, or not power rule, excuse me, product rule. Alright, let's do some simplification. X will go numerator to 1 minus x squared to the 1/2. So negative x must be thrown in the denominator as we should. 1 times anything's itself. That's lovely. Now let's get a common denominator so we can add them. That's going to be 1 minus x squared, because I'm multiplying this by square root of 1 minus x squared over the square root of 1 minus x squared. I'll take care of the 2 in a minute. We'll worry about that when we get there. 1 minus x squared to the 1/2. And now let's take care of the 2. So multiply top and bottom by 2. So this will change this to a 2. Put a 2 down there and a 2 right there. So when we get like terms, we're going to get negative 2x squared plus x plus 2 over all that. Fine. Ooh, I did forget one thing. Oops, I just noticed it. Did you catch it? Right here. I didn't multiply by what's on the inside. My bad. So, times 2x. So that's going to make this 2x times x is 2x squared. Thus, we don't need that 2 there. So, how does that change things? So that's going to be x squared there. I'm going to erase just to make our lives a little easier. Which is going to be 1 minus x squared. And then, of course, we don't have a 2 here anymore. And that's going to make things a little easier. So it's going to be negative x squared. That was a negative 2x, my bad. Should have been a negative 2x. So it's going to be negative x squared minus x squared. And that will end up being a negative 2x squared plus 1 over 1 minus x squared to the 1/2. There's your final answer. And this problem I'm going to have you do on your own. And what I want you to find when you do it on your own is I want you to find the second derivative of this function, okay? So yes, you're going to have to apply your chain rule that we've been doing over and over again, but you also need to find a second derivative after that, okay? Good luck. Looking forward to seeing you, and take care. Bye-bye now.